Today we get to solve compound inequalities. So this is 6.4. Compound inequalities. When you hear the word compound, you know this from language arts. You know we have compound words or compound sentences, right? What's a compound word? Give me one. Give me an example, Sabrina. Mailbox. It's compound because, why is it compound? Mailbox, Sabrina, why is it compound? And box. Okay, so we've got two words coming together to form a word, right? Ryan said basketball. Basket and ball. Brandon said, okay. And so we have two words making one, right? So compound inequalities will be more than one inequality coming into the same inequality. Okay, so the same statement. There's more than one thing taking place. They are combined by either and or. This reminds me of compound sentences in language arts. Can someone give us a compound sentence? Lauren. The algebra class will hear a lesson and the class will complete an assignment. There you go. The 8th grade will attend school, or the class will go to Knott's Berry Farm. Oh, there's compound. Okay. So let's start with compound inequalities that have and. We have both of these, and they're going to look different. And or are different, aren't they? I mean, if you are going to have a really fun time, the 8th grade is going to Disneyland and Knott's Berry Farm. Would you rather do that, or would you rather the 8th grade go to Disneyland or Knott's Berry Farm? And. Why would you like to do the and?
Because it's both.
You get to do, well, it's more for you, right? You get to do two things, right? So let's see if we can put this into a math statement. All real numbers greater than or equal to -4 and less than 4. We're going to graph these solutions. So how could you write this inequality? All real numbers. So something is representing all real numbers, and that's usually a variable, right? So we have all real numbers, and we could call them x. The numbers that are greater than or equal to -4 and less than 4. So how do you write that? Ryan. Follow that on -4. And then we don't know how far to go, but we're going this way, okay? And then what else could we do? To the left, we're going this way. So look at that, we can meet, right? We can meet. And if you're going to satisfy both being greater than -4 and less than 4, then you have to be something between those two, don't you? You could be -4, but you can't be 4. So how do we write this as an inequality? Sophia. I think we usually start with, I like how you are saying this as a 3-part. We usually start with, just like a number line, the smallest number on the far left. So could you give it to me that way? -4 is? Greater than or equal to? Or less than or equal to? So that now we read this from the x perspective, right? X is greater than or equal to -4. Does that work for you? Okay, so good. X is greater than or equal to, we did say we were going greater than -4, so this is good. And less than 4. This part's easier. We're used to starting with the variable. Okay, so notice we can put this statement into one three-part inequality. We have a lower end, an upper end, and all the values lie between. And the graph looks like a segment, doesn't it? One end has a solid dot, one end has an open dot, because one inequality here has a equal sign under it and the other one does not. So that changes the endpoints, but otherwise we have a beautiful segment, okay? Okay, so and inequalities give, look at this, the intersection of graphs. Intersection. An intersection, when you're driving down the road, you're driving up over the hill, Encinitas Boulevard, you go down where the light is and there's El Camino Real, right? That's an intersection. Both of those roads contain that they contain that point, don't they? So both of these inequalities contain these points that you see on the segment. Because it's an and, the solutions have to work in both. Some of you might have written this as x is greater than or equal to -4 and x is less than 4. Did anybody write it like that? Two separate ones? Okay, this often happens as you're writing them. And then you have to ask yourself, could I write this as one three-part inequality? And because you can, you should. And this is going to be the standard form, least to greatest. Okay? And you put the x only once in the middle. But that doesn't work for all compound inequalities because we have or. Okay? So compound inequalities with or. So here's our example. All real numbers that are less than -1 or greater than 2. So what does it look like on the graph if you are less than -1? Jonathan, how do I graph that? What type of dot at -1? Open. And then which direction do we travel if we're less than -1? Pointing left, good. Left, this way. Okay, and then how about greater than 2? How do we do that, Chad? What type of dot?
It's going to be a circle. It's going to go
To the right. So is this the intersection of solutions? They're not combining, are they? Can you be less than -1 and also greater than 2? If you are a number that's less than -1, can you also be greater than 2?
No.
That's not possible, is it? So this is an or inequality. You can be one or the other, but you can't combine the solutions, can you? You can't be both, like you can in an and inequality. So let's write the inequalities. Who has tried? Give me one of these, or give me this inequality. I don't know how you're looking at it. Casey, what can we do? Okay. Greater than 2. Now, could we write this as one three-part inequality? Look at how it looks if we try. We could put x in the middle, put the smallest number on the far left, put the largest number over here. But now x is, she said, less than -1. So look at how that looks, right? And then x is greater than 2. But really, are the values in between those two numbers the same? If you are greater than -2, you are not less than -1. So this just does not work, okay? When we have an or inequality, we have two separate little inequalities that we write. And you can see that the graph is two rays going opposite directions. So you need one inequality for the ray moving left, and you need one for the ray moving right. We call this the union of graphs. We're saying that the solution could be over here all these numbers, or over here all these numbers. Okay, so let's try again, and you need to write the statement down or you don't know what you're graphing, and it will be not very useful for you. So all real numbers that are less than -1 or greater than or equal to 4, So you can see the word or right there. So show me with your arms, is it going to be an intersection or a union? It's going to be a union. I mean, look, we're definitely an or means we do not have a segment that is overlapping solutions. We're going opposite rays. Okay? So will we have one 3-part inequality or 2 little inequalities? 2 little inequalities, right. So give me one of these little inequalities that we will have. Isabella.
X is less than or greater than 1.
Okay, and do you want to give me the other one?
Okay, and then X is greater than or equal to 4.
Good. So we want to see those numbers here, right? So let's graph x is less than -1. What type of a dot do we have for that, Christina?
An open dot.
Okay, and then which way does the ray go?
It goes to the left.
Good, x's are less than -1. And how about x is greater than or equal to 4? Izzy?
Closed,
Closed dot,
and it's to the right.
and to the right. Okay? These two inequalities do not share a solution. So we do not put them in one 3-part inequality. Okay? How about all real numbers that are greater than or equal to -3 and less than 5? So, can you be greater than -3 and less than 5? Can you be both? So, with your arm, show me what this will look like. Will it be rays or a segment? It'll be a segment, right? Coming toward each other. Okay? So, this is an and. So, who can write that inequality for us? Nick.
It's -3.
So you put the -3 on one end and put the 5 on the other end with your variable in the middle. Good. And now tell me the signs.
So you do x is greater than or equal to 3, and you do x is less than 5.
Good. And when you have this in order from least to greatest, your inequality signs will always kind of progressively grow like that. They'll look like less than signs, like that. Okay? So, or less than, or equal to, like we have here, right? So. So we need to be able to see 5. I don't know what to do here. How about 0, -3, 3, 6, 9. Just make sure your scale is consistent between the dashes, right? And so can we estimate where 5 is? So what type of a dot do we put at -3? Jimmy?
Solid.
Good. And then which direction? X's are greater than or equal to. You've got to read this in terms of where x is, okay? X's are greater than that, so which way is greater? To the right. You said to the right? Okay, I'm sorry. And then x's are less than 5, so how do we write that, Bianca?
To the left.
And so we have to have what type of dot?
Open.
Open dot at 5. I'm going to label that 5 there. And to the left. Good. So there it is, a segment. 3-part inequality and a segment. Any other questions, or was that what you were going to say? This is on the wrong spot. Oh, look at how it didn't erase the blue. There. It should not go beyond -3. You're right. That was an error. My fault. Real world model. So please take this down. This is the final note, I believe. Yes. So, yes, we can find inequalities in the real world. At an auction, the lowest bid for an autographed trading card is $20. The highest bid is $54. Write and graph a compound inequality that describes the possible bids. Okay, so I see some of you writing an inequality. Can you be both, or they have here a lowest bid at 20 and a highest bid at 54. So could you be a number in between 20 and 54?
Yes.
You could, that's how that works, right? If you have a lowest and a highest. We call that a minimum, you know, here's a minimum, and then we have the maximum. So because we have values that could be between, what type of an inequality is this? Is this an and or an or? It's an and, it's a three-part one, right? So your bids are falling between those two, the minimum and the maximum. Okay, so who can fill in the inequality signs? Check.
20 is less than or equal to B, and 50 is greater than or equal to B.
54, okay. So there, so now you just go graph it. What types of dots will we have on the segment, everyone? You see, they're closed, so make sure you put them, make them close 54 and 20, and then we have all the bids in between. And it's a segment. Okay? Very good. And there you go. You should have time to do this here.